In this video, I want to go through the Table.Partition function in Power Query, which I got from a guy called Brian Julius from DC on LinkedIn, who posted this image. I didn't fully understand the function to begin with, so I tried to play around with it, and that's what I want to go through in this video. My table has one row for each day of January in 2024, and then I have one row for February. And I'm going to then partition this table. In other words, I want to split this one table into multiple subtables based on a criteria. First I want to do it on month, then I want to show what's a bit trippy with the function. First want to load the table. I first want to show the helper file, since I don't have IntelliSense in Excel 2016. So it says to position the table based on the value of a column and a function. And I tried googling this hash function, which wasn't helpful. The function essentially does a modulo operation and then divides based on the remainder of the division. In this case, I want my table to be the previous step, and I want the column that I'm basing the first partition on to be the month, meaning I'll have one table for each month, which will be passed in as a string. Then I need to specify how many groups, and conveniently I have exactly 12 months. I can write that in. And my actual function is simply going to be to take the value of the month and then do the modulo operation using 12 as the divisor. Since I've selected the month here as my column, the underscore then refers to the value in the month column. And I forgot a parentheses. We now get 12 rows, which is what I want. And if we check, a lot of them will be empty because I only have data for January and one row for February. And what I would expect is that the first row would be January because that's the first month, but this is actually empty. All of my January data are in the second row and my February are in the third row. The way it works is that, well, you take the month of December, which is 12, you divide that by 12, which leaves a remainder of 0, which means that December would be in the first row because the remainder is 0. January has 1 divided by 12, which means the remainder is a 1. So it gets put in the second row because 1 is the second lowest remainder you can have when you divide, and so on and so forth. So December will be the first row, November will be the last. And like I conveniently wrote in my notes, this is a bit confusing. So optionally, you can instead say, if we just copy this as a new step, optionally, instead of saying each underscore, I can say each underscore minus 1, which will then put January in my first row and December in my last. Because now for January, I'm saying month 1 minus 1, which is then 0 divided by 12, and there's no remainder. And for December, I would have the month 12, minus 1 is then 11 divided by 12. That's a remainder of 11, so it gets put in the 12th row because remainder 0 gets put in the first row. Another way to partition the table would be to look at the day column. So maybe I want to divide this table into 4 groups based on the day. So we can just copy the code as before and say now instead of the month column, I want to look at the day column, and instead of 12 groups, I want 4. And I just want to use the value in day column to do my partition. So now I get 4 rows, and in my first row, I have all of the days that can be divided by 4 and leave a remainder of 0. So 4, 8, 12, 16, and so on. And in the second group, I then have 1, because that leaves a remainder of 1, and then a remainder of 2, and a remainder of 3. And then you could do something like referencing this query, and I can say I want to filter on the first value. And actually, I guess I can't actually filter it because these rows are tables, so I can't filter a value, but I can use the curly brackets to say extract the 0th row, and then I want to unpack it by simply clicking it. And then I could say first partition here, and then repeat this 3 more times. Lastly, I want to show that you can also do a proper function. Instead of simply referring to the current row, you can do an actual Boolean calculation. So maybe instead of having the first day, 5th, 9th, and so on in the same group, maybe I want the first 5 days in one group and the next 5 days in another, and so on. By saying that I want 6 groupings because there are either 30 or 31 days and it starts at 1. So this is almost evenly distributed. Then here, instead of saying each underscore, I can say each if the underscore is less than or equal to 5. I want to return 0 because then I will have 0 divided by 6, which leaves a remainder of 0, so it's the first group. And else, if the value is less than or equal to 10, then print a 1, so 1 divided by 6 leaves a remainder of 1. And then because my first condition is to check if it's less than or equal to 5, that means the value has to be 6 or greater for the next if to activate, and then I can keep going like this. With this setup, I will have the dates 1 through 5 and 31 be in the same grouping, because in this last if portion I'm saying if it's less than or equal to 30, which means that 31 is going to be 6, and 6 divided by 6 leaves a remainder of 0, which is the same as being less than or equal to 5. So maybe that's a bit silly. So I could actually turn this around and say that if it's greater than 25, then it should be a 5. But I can also just delete this portion and say that if it's not less than or equal to 25, well, then it's 26 through 31. Then I can replace the if with the symbol else 5. Now I still have 6 groups, but the 31st day is along with group 6, which I think makes more sense. So the trick to the function is that it uses modulo, which means you need a column with a number so you can divide it, otherwise it's going to break. So it's convenient if you have a day or a month. On the example he used, where he looked at whether a stock was positive or negative, then he divided them into 2 groups. So